Hello, everyone. You are welcome to this afternoon lesson. And in this lesson, we are going to look at enlargement and similar figures. Okay, enlargement and similarities. Okay, some books, that is how the topic is. Okay, so now, I think in JHS, you did enlargement and the transformation. And you should know that anytime we talk of enlargement, okay, we are talking of what? A scale factor. You cannot mention enlargement without what? Okay, considering what? The scale factor. Okay, we have enlargement and what? And reduction. Okay, so let's move on. The first part, in fact, I even wanted to give it to you to read. Okay, but I will just walk you through, okay, take you through the salient parts, then that will be it. Okay, so we are looking at enlargement and similar figures. And as you can see here, okay, in this figure, we have an object and what? An image. And you know, when you did transformation, okay, your original object, okay, or figure will be your A, B, C. The image is where you see the primes. Okay, either the subs or the prime. So it means A prime, B prime, and C prime. Okay, let me put it, this is supposed to be C prime instead. Okay, and C prime, okay, is the enlarged figure of what we have here, which is ABC. Okay, and every enlargement, you should have what we call the center of enlargement. So here, the center of enlargement is O. And your center of enlargement is critical because where the value of what? The sign, I should say, not the value per se. The sign of what? Your scale factor. Okay, and very soon, okay, from this you know. Okay, but I don't think I'll read the whole of this. So I will just make my point and, okay, that will be it. So enlargement, we have, okay, magnification and what? And reduction. Okay, so enlargement is made up of what? Two. Because your scale factor can be less than, okay, 1. Or can be a fraction. In that case, okay, it will result in a reduction. Okay, if it is greater than 1, then it's going to give you more or less, what do you call it, magnification. So take note. Okay, so for every scale factor, okay, you are supposed to have your K to be equal to your, what we call the image length. So the length of the image. So image length, let me use image. Okay, then you know that in geometry, we use this to represent length over the object length. As simple as that. So if you know this, you are good to go. Okay, only that you should also know that if your objects are located, okay, on the same side of your center of enlargement, then the sign will be what? Positive. Your scale factor will be positive. If it's negative, then it means your object, okay, your object and its image, they are located, okay, on the opposite side of what? Of your center of enlargement. So if you look at your center of enlargement, the triangle ABC and A prime, B prime, C prime, okay, which is the image of this triangle, they are located on the same side. So if you find a scale factor, you are going to get what we call, okay, a positive what result. So from this figure, we can say that, okay, if I take this length, okay, you can see there is A prime, B prime, interested in the image length. So A prime, B prime. And the corresponding side, yes, B prime. The corresponding side, okay, will be, what is it? No, so this is C prime, A prime, B prime. The corresponding side will be A, okay, B. So you use corresponding sides to form what? Your, okay, ratio, which will give you your scale. So this side is 8, okay, over the object, okay, corresponding side, which we have here to be 4. Okay, I think it's not clear. Okay, so let me write it well. This is 4. So you are going to get what? This over 4. And you can use, okay, 2 corresponding side, and that will always give you the same scale factor. So just as you have here, your scale factor K will always be the image length over the object length. And this is something that you know. And even in IS, okay, you do that as well. So this takes us to our next slide. Okay, so with this one too, you are just asked to find the scale factor. And you know that here, this is your center of what? Of enlargement. And your objects, okay, and the image, they are located, okay, to the same side or on the same side of your center of enlargement. So your scale factor will be positive after looking at the image length over the object length. Okay, so if I'm looking at the object OA, its corresponding image will be OA prime. So OA, I know, the natural fact is the numerator, that must be the, what do you call it, the image. So OA prime will be 2, okay, centimeters plus 3 centimeters. So that will give us what, 5. Okay, over your OA is 3. So that gives us 5 over 3. And that will be your, what do you call it, scale factor. And with this one, unlike the first two, you can see that here, this is the center of enlargement. So from O, okay, where the objects are, I mean, the object is enlarged. Okay, from that's your center of enlargement. So here, OAB, okay, is the object, and OA prime, B prime is what? Is the image. Is that clear? Do you agree
Yes,
with me? Hey, are you sure? Are you sure? Is it because you don't know, you can't answer the question. If I ask you 1 plus 1 and you said 2 and I tell you, are you sure? You even allow me to laugh. You say yes. But because you are not, okay, too strong, that's why. Okay, yes. Because even the question says so. In the diagram, OA triangle, O prime, okay, it's not O prime, it's OA prime, B prime is the image of triangle OAB. So this one, no one should confuse you. It's stated there. As simple as that in plain language. So if you are looking at this object length, which is AB, the corresponding image length would be what? A prime, B prime. So this image length over the object length should give you a scale factor. However, because the object and its image, they are opposite each other, okay, based on the center of enlargement, your scale factor will be negative, you don't forget. Is my point well made?
yes, please.
Okay, now we move on to, okay, the areas and volumes of similar what figures. So this one, all that you need to know is this, okay, your scale factor squared, okay, will always be equal to the area, the image area. So I'm using, okay, let me write image area. Okay, over the object area. So it's the same thing. You can see that the scale factor squared, area deals with what? Square units. Okay, so once you square your scale factor, then you are now dealing with what? So I said object area. You are dealing with what? Area. So image area over object area, as simple as that. And okay, I use this. You know that if the object is A, the area of the object is A, its image area will be A prime, as simple as that. So it's the same thing, only that you can see A, okay, 0, but you can take care of the 0, you can ignore the 0, and that will be your object area and the image area, as simple as that. And the volume will be cubed. So once you, okay, cube this one, then now the ratio becomes no longer, okay, the image or length over the object length. It's rather the image volume over the object what volume. Is my point well made? So indirectly, K cube, your scale factor cube will always be equal to the volume of the image over the volume of the object. As simple as that. Okay, so okay, you can make use of this concept, okay, here. So let's see. A circle of area, okay, 63 centimeters as an example, worked example. Centimeter squared is enlarged with scale factor 3. What is the area of the image? Okay, then B, in the figure B, okay, so this wasn't what we were looking at, so let's go back. Okay, so the first one, let's see if you can do the first one together, then we come to the second one. Okay, so The first
In
one,
fact,
yes, please. Can you hear me?
yes, please. But we're looking at the one with the square.
Oh, we're not looking at this. Are you sure?
No, please.
No,
Yeah,
that's
we were here.
I finished with this. Okay, with this one, I talked about the area, and this one is what's the volume. I talked about that briefly. So I just gave you the formulas. Okay, it's the formula that you should be interested in. We are going to apply or make use of that concept here. Okay, so a circle
Yes.
of area 63 centimeters squared is enlarged with scale factor 3. What is the area of the image? So you are looking at the image area. Okay, so you know that's per the formula. So let me look at solution to question 1. This is so easy. Okay, so question 1. You know that your image area, okay, over the object area should be equal to your k squared. Do you agree? Or k squared should be equal to this. Do you agree? Okay, but before you write this, I expect you know that you extract given area of a circle to be equal to this. Okay, scale factor k to be equal to this. That one you know. The low hanging marks, you can get it. So I have skipped that. Then we are going to get, this implies that you are looking at, or you are looking for the image what area. So you will get image area, that's the parameter that you don't know. Image area, okay, over the object area you are told is 63. Okay, don't ignore the units. Later you can deal with it. Then it's equal to what? Your k. Your k is what? 3. So you get 3 squared. Okay, so at this point, you know what to do. So it means I can write therefore my image area, okay, will be equal to 9, okay, times what? 63. Then whatever that you attach your centimeter squared. Is my point well made?
Yes, please.
Okay, very good. Then as for, I think the solution is even here. Look at that. Oh. Okay, so the solution is here. So you should be, only that be careful. You cannot conclude with this. Okay, you can't conclude with or the image area. This representing the image area. Okay, take note, you cannot. And the other one, I think, equally you should be. So the figure below, we are looking at area of a triangle, ADE. Okay, this is looking like, okay, not a proper E. Okay, it's 80 centimeters squared. Determine the area of triangle ABC. So obviously, if you look at this, if you take triangle ABC, okay, to be the image of triangle AD what E, then in this case, you are looking at reduction. Okay, then you should know how to deal with this. So take notes. You just have to substitute, find whatever, substitute. Okay, and in this case, you don't know your K. You are supposed to find your K. And you know that if, just like I said, if I take this as my object, usually you will be told. Okay, only that this one you are not told. Okay, so let me see if there is. Yes, Kezia, your logical reasoning is not reasoning. You still want us to do logical? We are done. We finished logical reasoning yesterday. Okay, so let me see if I'm recording. Okay, so we finished that. So we are looking at another topic. If you have issues, okay, let's talk backdoor. Okay, all right. Okay, so that's it. So I think with this, you should be able to deal with it. I'm not here because of this. Okay, this one not too technical. When you read your various textbooks, you can deal with it. So now let's go and look at what. Okay, you try this question and this one later. So these are, okay, the sort of questions that I want us to know. Okay, but before that, I think I should have created, okay, so hold on, let me pause and do the needful. Okay, I thought maybe, I think I deleted it. Okay, so now this is it. I am going to walk you through how to identify, okay, similar figures, or how to say that, okay, two figures are what are similar, how to make that determination. Okay, so please take note. Assuming I have this figure, similar is not the same as equal. Okay, take note. And you are told that this is parallel to that. Okay, how many triangles can you see? So let me call this, okay, A, B, C, D, E. How many triangles can you see in, okay, this
2.
figure? 2. Okay, please, do you all agree? Do you all agree that you have 2 triangles that we can consider? Okay, so I'm going to separate, okay, the triangles. So the bigger triangle, okay, which is triangle ABC, okay, and the smaller triangle, okay, which is triangle what? ADE. Do you agree? Okay, so here you have to be very careful. When 2 figures are similar, here I'm using triangle, okay, and by extension, okay, quadrilaterals and what have you. If 2 figures are similar, all that you need to do is to show that 2 of their angles are equal, or 2 of their sides are equal. If 2 of their sides are equal, automatically the third side will be equal. So usually we say that either all sides are equal or all angles are equal. But 2 angles being equal in a triangle will automatically mean that the third angle will be equal. So if I look at these 2 triangles, obviously I can say that because this line is parallel to this, the angle here is equal to the angle here. Do you agree?
Yes, please.
Corresponding angles. Okay, similarly, the angle here will be equal to the angle here. Is that clear? However, in geometry, okay, if I do this without putting values there, okay, there will be issues. Issues in the sense that in geometry, we'll assume, okay, that all the angles here are, okay, the same because they have the same number of arcs. So to indicate that, you know, when you are dealing with lines, to show that 2 lines are equal, okay, we use strokes. They should have the same number of strokes. However, in angles, if you want to indicate that angles are equal without writing the sides, you use same number of arcs. So this is equal to that 1 arc. If this is equal to that, then I'm going to have 2 arcs here, 2 arcs here. Is my point well made, or I should come again? Is my point well made so far?
Yes, please.
Okay, good. Okay, so now you can see that if I take this triangle, the smaller triangle and the bigger triangle, automatically you can see that they have 2 angles being equal. But you can also know that they share a common angle at A. So once the 2 angles are equal, automatically the third angle, which is the angle shared at A, will be the same. So in this case, triangle ABC is similar to triangle AD. Is that clear? Now, whenever, okay, triangles or figures are similar, if you're able to determine that the figures are similar, it could be triangle, it could be whatever. Once you make that determination that they are similar, then you can always form a proportion based on corresponding sides. In any case, what is a proportion, if I may ask? This is the only question there. What is a proportion? 4 marks question. This is the only question. What is a proportion? You know ratio and proportion. So what is a proportion? Ratio and proportion, they move together. The basic meaning of proportion. Oh, hurry up. You want me to mention names? The basic meaning of proportion. Oh, don't do that. Somebody answer your mom questions you should solve. Okay, anyway. You know, ratio is what? A over B. Anytime I have a quantity over another quantity is ratio. Okay, And I can have C over D. Anytime you equate two ratios, okay, you get what? A proportion, as simple as that. So a proportion is when two ratios are equated. Is that clear?
Yes, please.
Oh, yes. Okay, so now that you know. Okay, so this is it. Anytime, so we said this angle here, the angle at B will be the same as the angle at D. The angle at what? At C here is the same as the angle at E, having separated what? My triangles. Okay, but remember, I said anytime, okay, two figures or two or more figures are similar, let me restrict my explanation to two. Okay, you can always form ratio based on corresponding size. And here you are supposed to go and look for the corresponding size. Okay, and this is how you look for your corresponding size. This is the technique. This is the technique I tell or teach my students. Okay, if you can see that I can have AB. I have AB here. If I want to see the side that corresponds, okay, to AB that I have here in the other triangle, then this is what I do. AB here is the side with only one arc cutting it and no arc cutting it, so you can see. Let me do that for others. AAB, one arc cutting it, no arc. AC, you have two arcs, then no arc. BC, you have one arc cutting and two arcs cutting. I don't know whether you get my point. Please, are you following?
Yes, please.
Okay, I won't ask whether I should come again. Should I come again?
Yes, please.
Okay, so if you look at the size, okay, they differ. And this is how you identify the different size. Okay, not only with the letters, the naming. Okay, but if you look at this side, okay, there is no arc, okay, cutting. Okay, and there is one arc. So no and one arc. If you come to this side, you have no arc cutting it and two arcs cutting. If you come to this side, you can see that one arc cutting and two arcs cutting. And if you come here, you can see that you have a similar situation, if not same. So if you want to identify, okay, the corresponding side, then they should be the side with the same property. So if I'm looking at the side AB, the AB here, okay, will correspond to, okay, and in geometry, we use this to indicate correspond. Okay, will correspond to, not is equivalent to, correspond to a particular side here. AB here is the side with only one arc and no, okay, arc. So you can see that it's rather AD, that it will correspond. Do you agree?
Yes, please.
Okay, so you get the point. So now let's look at AC. AC will correspond to which side? Based on the explanation. AE, very good. With this one, you can easily see it, okay, without, okay, even doing all that. But when it comes to theory questions, it will not be easily identified like you have done over here. So very soon you know. Then the last one, obviously, will be BC. And BC correspond with what? With DE. All correct?
Yes.
Okay, so now that you know the corresponding side, this is what we are going to do. You can form, like I said, you have to form a proportion based on corresponding side. And I repeat, based on corresponding side. So you don't just form your proportion. Okay, so this is it. If let's say I come and take the length of AB, okay, over the length of BC. Okay, I've formed a proportion using, okay, two of the sides here. Is that clear? The proportion that I'm going to form here, okay, should be similar to what I have here, meaning the AB, which is the numerator, it is the corresponding side here in this triangle that should also appear in the numerator. So the corresponding side here will be AD. Okay, the corresponding side for BC, we said will be what? DE. So here we can say that this will automatically be equal to that. you can form your proportions in so many ways. You can have what? Again, I can do AB over AC. Okay, and this must be equal to AB over AC. You know AB is AD. Okay, in terms of the corresponding side here, over, what is the corresponding side of the AC, which is the denominator?
AE.
AE, so it means AE here should also appear in what? In the denominator. So you take notes. Okay, and like I said, you can play with it. Just make sure that when you form your ratio here, the other ratio that you are going to deal with, the numerator should correspond and the denominator should correspond. That's all. Once you're able to do this, then the rest of the work will be very easy. Okay, so now let's go and look at how best we can make use of this information to deal with this. Okay. Now let's look at this question. Obviously, okay, a past question. Okay. In the diagram, angle ABC, sorry, BAC is 90 degrees. And okay, let me skip this. When you mature, I'll come to this. Okay. Okay, so let's look at this one first of all. Okay, it's not looking that pretty, but you should be able to deal with it. Okay, all right. So in the diagram, angle YXM is equal to angle X. So YXM is equal to angle XZM. So obviously you can see, even if this statement is not there, by the nature of the arcs here, you should know that they are the same. Two arcs here, two arcs here. Is my point well made?
Yes, please.
Okay, YZ is a straight line. So where is your YZ? This is a straight line. Okay, then the length of XM. So you know XM. Okay, is this, then the length of Y, okay, sorry, XZ is 10. Okay, you've been given the measures there. We need to find, okay, the value of W. So where is W? You want to find this. Okay, you want to find this. And anytime you see questions of this sort, where you see angles, okay, maybe with double arcs and what have you, the first thing that should come to mind should be enlargement and similar figures, or just similar figures. Okay, so in this situation, it is your duty to get the triangles that are similar. If you are not able to identify the similar triangles, then you wouldn't be able to identify the corresponding side. That will help you form your ratio, and that will help you find your unknown. So here, if you look at the diagram that we have there, how many triangles do we have? Can you see? How many triangles?
2.
2? I can see more than that.
3.
3. You can see a bigger triangle. Okay, then this smaller triangle and another smaller triangle here. Do you agree now? Okay.
No.
Now, did you say no?
Yeah.
Oh, the bigger triangle. So one triangle is, so I have triangle XYZ. That is one triangle. I have triangle, okay, XMZ. Then I have triangle, okay. Can you see now? Okay, so XYM. So these are the 3 triangles. But usually, okay, 2 of them will be similar. Okay, 2 of them will be similar. Okay, so now it is our duty to identify the similar triangles. And take notes, okay, if you are going to form your similar triangle, okay, always the 2 triangles that are similar, they will share a common angle. So look for that common angle that is shared by the triangles. If you look at this, you can see the triangle. Okay, I said this one is X, Y, M. Okay, if you look at this, you can see the 2 of them. Okay, you can see Y between them. Can you see that?
Yes, please.
So it means it is these 2 triangles that share a common angle at Y. So it will be these two triangles that will be similar. That is one way, okay, of identifying the easiest way. Check whether you have a common, okay, angle shared by any of the triangles that you are considering. So once you get that, then it means it will be these two triangles that you are supposed to consider. So I'm going to do something here. Please try and relate. Okay, so my triangle. So I'm going to draw the two triangles, separate them. Usually it's better. Once you do that, your work will be very easy. You can easily identify the similar figures. Okay, so I have one triangle here. I said X, Y, Z, which is the bigger triangle. So I'm going to draw that. It's not drawn to scale, you should know. Okay, so X, Y, okay, Z. Okay, and X, Y, Z, if you look at it critically, you can see that you have two strokes here at Z. Is that clear? Is my point well made? Hello, is my point well made? Okay, and let's see whether we can bring in the length. We know XZ to be 10 cm. Okay, then what else? We know YX, okay, to be W. Okay, or XY to be W. And we also know, okay, this to be 15. Okay, WCM. Okay, now let's go to the other triangle, XYM. So X, okay, Y, what, M. Let's see what we are going to get. So we are going to draw that one as well. So XYM, this is the nature, okay, of XYM. Okay, so X, Y, okay, M. And you can see that X, Y, M, you have two, okay, arcs here. Is that clear? Hello, are you with me? You are not responding. Are you following? It seems I'm having network issues, so please respond, okay, as soon as possible. Okay, so now, okay, this is what we have. Let's see if you can get any measures. We know XM, and that is 8. Okay, what else do we know? We know X, okay, Y or YX, which is the same as the W that we have there. Any other known side? Do we know YM? We don't know. I hope you are with me.
Yes, please.
Okay, so now this is it. You can see that these two triangles, obviously they have two angles to be the same. The common angle Y here and the one that you have the two, okay, arcs. Is that clear? Is that clear?
Yes, please.
Okay, so this is what you do. Okay, the common angle, you are going to leave it like that. The other angle, which is here, okay, automatically will be equal to the angle here. So this angle here will be equal to this angle. Do you agree? Because we know that this, okay, so you know that two of the interior angles of this triangle, okay, and this triangle are the same. One angle here, okay, is equal to this angle. And also the angle Y here is the same as the angle Y. Can you see that even from this, you know that they share a common angle at Y? That's what we use to split, okay, our triangles for the similar figures. So, and I'm saying, do you agree that two of the angles will be equal? This and this and this and this are equal. So automatically the third angles will be equal. You get it?
Yes, please.
Okay, so this is what you do. I'm going to indicate the equal nature of this by using 3 arcs. It will help me going forward, 3 arcs. Is that clear? Hello, is my point well made?
Yes, please.
Okay, so now this is what we are going to do. Once you do this, your corresponding sides are easily, okay, identifiable. You should know this. So remember I said you use the strokes. So let's try and pick the corresponding side. So XY, obviously, let's see XY here, correspond to, so XY, what do we have? Look at the XY here. Do you see any side that it corresponds? Because you see XY here, okay, so let's see. That doesn't mean that's the corresponding side because they have the same XY. Go and use the arcs. So the XY here, you have how many arcs cutting it? You have three and no arc. You get the point. So you come here where you have three and no arc will be YM. You get the point. Are you with me?
Yes, please.
Okay.
Yes, please.
Should I come again?
No, please.
Okay, you are fine. Okay, so I heard another voice. I thought maybe. Then this side, X, okay, Z. So XZ, you're identifying the corresponding side. It will always help us form our ratio and therefore the proportion. So if you look at XZ, it's the side with 3 arcs cutting and 2 arcs cutting. So if you come here, both sides, okay, has what? 2 arcs and 3 arcs cutting at the same time.
XM.
XM. So XM will be the corresponding side. Okay, so automatically the third one, okay, you will get it. So the third one will be YZ. Okay, so YZ will correspond to YZ. You have 2, okay, arcs and no arc. So 2 arcs and no arc will rather be XY. Is that clear? Is my point well made? Okay, so now this is what we are going to. Once you're able to identify the corresponding size, though you are liberty to form or you can form series of proportions, but you form your proportion in such a way that, remember the sign rule, you form your proportion in such a way that there will always be one unknown. There will always be one unknown, then you go and find it. So usually this is what I tell my students. Okay, come here. Look at the size that you have to, I mean, you know their values directly. So this one is what? XZ, okay, and Y what Z. So I'm going to form a ratio based on these two known size, and let's see what will happen. So YZ, okay, the length of YZ over the length of what? XZ. Okay, this should be equal to, okay, you can see that this and this I know. So let me come here and see. YZ, what is the corresponding side? XY. Do you agree? Okay, we've made that determination here. Okay, then your XZ, what is the corresponding side? 3 arcs and 2 arcs. Okay, that will give us XM. So we have XM. All correct? Are you all with me in terms of the, okay, so in this case, I can now come and write, this implies that the length of YZ, okay, I know is 15, over the length of what? XZ, which is what? 10, should be equal to the length of XY, which is W, what I'm looking for, over the length of XM, and XM is 8. You just go and solve. As simple as. So if you continue, okay, we know the side can be simplified, and that will give us 3 on 2 is equal to W, okay, on 8. So what do? We are going to cross multiply. So you get 2W is equal to what? 24. Am I right? Okay, so you are looking for W. You write it again before you divide. Don't forget this. So over 2. So it means W will be equal to 12. Is that clear? Okay. However, you can see that, can you write there for W is equal to 12 centimeters? Is that how you conclude?
No, please.
Okay, obviously you cannot bring the centimeters, because if you bring the centimeters and you come and replace that here, then you are going to get, okay, 12 centimeters. So the W will be 12, because here, if there was no centimeters here, then you write what? You add what? The centimeters, or attach the centimeters. Okay, Kobe, I guess you've done enlargement and similar figures. Okay, all right. So then Okay, is that how you were taught?
Okay, so for enlargement and similar figures, the teacher gave it to us as a project work that we should do it on our own. So I learned it on my own basically. He didn't give us any tricks whatsoever. So this is new to me.
The tricks are new to you. I just want to know that maybe you are learning something new. That's it.
Oh, I am learning.
Okay, all right. Okay, all right. We thank God. Okay, so this will be it for this particular question. Now let's move on to our next question. Okay, so good. Okay, so this one is similar to what we have. Okay, yes, so yes, please. Should I go back?
Yeah, I want to.
Are you writing?
Yes, please.
Okay, you know you have to capture now. So just capture instead of writing, so that later you can write. Okay, unless maybe you are using a laptop and you don't have a phone. Okay. So let's cover. Okay, I'm praying the lights comes anytime soon. Okay, all right. So now this is what we have for the second question. Okay, in the diagram, so is the information provided here that will be here anyway. That doesn't mean you shouldn't read it, please. Okay, sometimes there will be a hidden information here. So make sure you connect the two. Okay, what are we supposed to do? We need to find, okay, the length of TR. So this small length that we have here. So our first task is to look for the similar triangles. And I said, anytime you want to look for similar triangles, look for a common angle shared by, okay, your triangles. Even with this one, how many triangles can you, okay, identify?
Three.
Three. Okay, so mention them.
Two.
They said three, so maybe they are seeing three. Maybe I am not good. I don't have a good side. So let's see. So mention them.
Please, QST.
QST, that is perfect.
And QPR.
PR, okay, that is another one.
It's just two.
Don't worry, even if I give you your entire life, you identify the third one. So it is two. Okay, it is two. The fact that this is not a triangle, it's a quadrilateral. Can you see that? Okay, so now that we've identified, so let's see how easily we can take the question home. So always, my advice is separate your similar triangles. So I'm going to do same here. So you shouldn't necessarily draw it to look like what you have there. Okay, only that if it looks like that, it's usually better. Okay, so I have, okay, let me do same. Okay, quickly, let me draw it in such a way that it will be having a similar look. Okay, so what I have here, okay, so let me see. Oops. Okay, so I'm going to have, I have something of the sort. Let me draw the bigger one first. The bigger one is of this nature. Okay, so that gives me PQR. And when you are drawing, it's not drawn to scale, so you shouldn't bother yourself much. Okay, the fact that this is bigger and that is smaller. So you have something of the sort. Okay, as what your QST. Okay, so now let's see the angles that we can easily identify. The angle at P, okay, you can see two arcs there. Okay, the angle at what T, you can see two arcs there. Is that clear? But already, yes, you know, before you started, remember I said, look for the common angle shared. And these two angles, they share a common angle at Q. This triangle, these two triangles. Do you get it? Okay, so yes. I will maintain that no arcs. So once two of the angles are the same, then it means, okay, the third angle automatically will be the same. So here, my third angle for this particular one is this. So I'm going to, okay, do this 3 arcs. Okay, my third angle will be here, 3 arcs, so that I can easily identify the corresponding side based on the trade. Okay, all right. So now what do? We are going to look for the corresponding sides, and let's look at the measures that we have. So quickly, this triangle, any measure that we know QP, and that will be 4 plus what? 6, is that clear? So this is 10. All correct?
Yes.
Okay, then do we know, what do you call it? Q, okay, R.
No.
No. However, if I know this angle, I mean this side here, the length, if I label this one as X, then I know that. So that's what I'm looking for. So I'll go and write, okay, X be equal to the length, okay, TR, what I'm looking for. So in that case, I can say that what I have here is the same as 5 plus X. Do you agree? Oops. Are you with
Yes.
me? Okay, so 5 plus X, if you like, can put it in brackets and write centimeters. Okay, so let me see. I have a message there. Okay, all right. Someone is already done. Okay, so now this is it. So the next one, what are we? Do we know PR? We don't know. No idea. Now let's come to the other triangle. The other triangle, similar triangle. QS. Do I know QS? Where is QS? QS, I know. That is 4. I hope you are following my professors.
Yes, please.
Okay, then, okay, do I know QT? Yes, I know, that is 5. Okay, any other ST, I don't know. So you can see that if I look at this triangle, this is the one that I know 2 of the sides. So I'll first of all form, okay, a ratio based on the 2 sides here. Then I'll go and, okay, form a ratio based on the corresponding side, equate to form a proportion. So in this case, I'm going to write, but I know that the length of what, let me use QS, okay, over the length of what, QT, okay, should be equal to, so QS, the corresponding side, let's go and look for the corresponding side. Now you are mature, so you don't have to go in. So this one, I have 3 arcs, then no arc. If I come here, 3 arcs and no arc will be this side, which is the QR. Is that clear?
Yes, please.
Over, okay, if I come here, okay, here I'm looking at 2 arcs, then no. That is my QT. So 2 arcs, then no, will be this, okay, which is the QP. So you put QP there. Oops. Okay, it's P, the length of QP. Okay, so now this implies that you go and substitute. What is QS? We know QS to be 4. Ignore the unit for now. And over QT, QT is 5. And that should be equal to QR. Remember, we said it's 5 plus X. So 5 plus X. All over your QP. And QP is what? It's 10. So 10. At this point, you don't need my help. Okay, you should be able to continue from here. So what do? Okay, you can't simplify this. You can't say, so we are left with cross multiplication. Anytime you are cross multiplying, please don't do this. Don't do this. JHS is allowed. Here it is not allowed. Okay, we can assume that you've canceled your work. So just cross multiply mentally and solve. That's my point. So this will give us 4 times 10, which is what, 40. Okay, it's equal to 5 times this. Let me write it. Okay, as you mature, you can do it mentally. Okay, which will give you 40 is equal to what? 25 plus what? 5x. Okay, so in effect, what do we get? We are going to get, okay, 5x, okay, will be equal to what? Okay, 5x will be equal to 40 minus 25, which is?
15.
15. You write it again before you divide. So x will be equal to what? Will be equal to 3. So you draw your conclusion, therefore, x is equal to what? Is equal to 3. Oh, sorry. Can we draw a conclusion with x is equal to 3? Okay, you can see that we introduce x, so we cannot. So we have to ignore. Okay, I mean, avoid doing this mistake. S came by way of your own introduction, and you should always avoid concluding with what you introduce. So that will give us, therefore, the length of TR, what we are looking for. Okay, it's equal to 3, but don't forget the unit, and that will be what? Centimeters. Is that clear? Afa?
Yes, please.
Okay, please, are we all fine? At this point, let me pause and ask you individually. Okay, we've done, okay, about an hour. Okay, so let's see. Okay. Okay, so here, okay, so you can see 3. 1, 2, and the bigger one. 3 triangles this time around, okay. But you can see that 2 of the triangles are right angle triangles. Do you agree?
Yes.
Okay, however, remember we are going to identify the similar, okay, triangles. And I said anytime you want to identify the similar triangle, what should be the first clue? What should be the first clue?
They should share an angle.
They should have a common angle. So if you look at your triangles, okay, let's see, are they sharing a common, okay, angle at Z or at Y? The way I'm happy for you people here. Okay, so figure out your triangles. Your triangles are what you said. Hey, let's mention our triangles. The bigger one that you can identify is X, Y, Z. The other one,
YXN.
okay, Y, X, okay, N. YXN, okay. Then the other one,
XNZ.
X, N, Z.
NZ.
Okay. So let's see. Any pair that you take. So let's look at this pair. Okay. Do you see, do they have a common angle? I think I have to pause then ask you questions. Okay, so maybe around. Okay, so you identify all the right angle triangles. Okay, so these are the right angle triangles. You try to get the angles that are equal. So the angle Y here in this bigger right angle triangle will be equal to the angle, okay, Y in this smaller right angle triangle, which is here. So this Y here, 1 arc, Y here, 1 arc. Okay, then the angle at Z here, okay, for the bigger right angle triangle should be equal to the angle at Z, okay, in the smaller right angle triangle. So this will have 2 arcs. Okay, sorry, this one, the Z, 2 arcs, and this, where is the other Z? This will also have 2 arcs. Is my point well made? Okay, so you said, so now let's see. The X here, obviously we can't say that it's the same as this. Okay, the X here is not the same as this. Okay, so now that we've been able to indirectly can see that this will be the 2 triangles that we can work with directly. This will be the 2, this and this. Okay, so now what do we have? Okay, this and this. Okay, I'm giving you clues. I don't want to spoon feed you. Okay, so help me deal with the rest. Indirectly, I've told you, when you know YX, okay, do you see any YX somewhere? Because in this similar, figure, you don't know even one side. Before you can form the proportion, and the proportion you are supposed to find xn, and xn is this. Okay, so this is what we are looking for. Okay, xn, let me call this maybe x, so that you know that we are looking for that. Okay, so before I can form proportion, the two similar triangles that I have here, this one is satisfying the condition. You know two sides. Okay, but the other one that you should know at least one side before you can form your proportion. Other than that, if you form, it will involve, two, unknowns. So what do? You can find yx here. Can't you find yx? You can find yx by going through the Pythagoras theorem. So if you find yx, you get ys to be equal to, so let me, by the Pythagoras theorem, I've told you any theorem that is named after a person, you appreciate the person. So by the Pythagoras theorem, it's capital P, Goras, and it's possessive. Okay, theorem. Okay, I think, let me see what the message the person has sent for me. Okay, so Pythagorean triple will tell you that you are going to get 4 centimeters. But I wanted to say it, but for some of you, maybe you wouldn't be able to relate. So let's write it. We know the hypotenuse squared, which is 5 squared, okay, will be equal. And because you are looking at, what do you call it? Different triangles, it's better you come and write from, let us know the triangle that you are dealing with. From triangle X, okay, sorry, triangle X, Y, Z. Let us know. That's the one that you are dealing with. It's usually better so that you don't struggle to look at. So the hypotenuse squared should be equal to, okay, what you have here, which is the length of XY, okay, squared. Okay, then plus what? The other one, which is what? Your 3 centimeters, okay, square, so 3 squared. Okay, if you are mature, you can, okay, put the refined version, which will be, okay, this one squared equal to this one squared minus this one squared. So you can start from there. So in this case, I didn't start from there. So you are going to get 25, okay, is equal to, okay, the length of xy squared plus what? 9. So I'm going to get the length of xy squared is equal to 25, okay, minus 9, which will give me the length of xy squared was 16. So xy, okay, squared, root of that will be equal to, whenever you are dealing with physical quantity, otherwise you would have introduced plus or minus. So you know that your answer should really be positive. So root of 16. So xy length will be equal to what? 4 centimeters. Is that clear? So it means this is 4 centimeters. Okay, this is also 4 centimeters. So now you can form your proportion. Okay, so let's see. The proportion here, I want to use this proportion. So the proportion here, so I will say that, but, okay, if I'm forming a proportion, my xy here over, okay, I usually want my unknown to be the numerator, but it doesn't really matter, but let me do that. Okay, so that change of subject becomes very easy. Oops. Change of subject becomes very easy. So you should equally adapt. Let your unknown, okay, always occupy the numerator. It's usually better that way. Okay, so my unknown is x, so I will use xn. The length of xn over the length of xy should be equal to, I come and pick the corresponding side here. I know this and this are similar. So the xy, I have 1 arc and 2 arcs. So it will be the same as yz. Do you agree? All over. Then the corresponding side, xn here, will be the same as what? So I have 2 arcs, no. Okay, and the 90. So 2 arcs, okay, then the 90. Okay, that will give me my xz. Okay, so this implies that at this point, I will leave you. Xn, what is that? X, you represented that by X. If you like, you can keep it as Xn, what you are looking for. So let me keep it like that. Otherwise, if I write X, you have to come and write, let X be equal to, I can't just write the X there, assuming maybe as if it was given in the question. So I will work with this Xn, okay, and conclude with that as well. Okay, over XY, XY is 4. Okay, it's equal to YZ. YZ is what? Is 5. all over, okay, xz, and xz is 3. So now you know that, okay, xn length, okay, will be equal to this times 4. So you are going to get 20 over what? Over 3. And you cannot conclude this. You are dealing with distance. So if possible, okay, leave it in terms of decimal. It's my point well made. So that will give us 4.3, okay, centimeters. All correct. Hello, my professors. Should I come again or my point is well made? So always, whenever you see questions like this, try to break, okay, the diagrams down, separate them. And once you do that, you are taking the question to your comfort zone. You can easily identify the similar figures by, okay, using arcs to indicate the angles that are equal and what have you. So on that note, I think, okay, we can end here. Okay, so this will be the last one. Okay, so I left this one for you. And with this one, the diagram is not drawn. You are supposed to draw. So let's see how you can get a picture, then your assignment will come. Already I've given you one assignment, which is this one. Okay, this one will be a class assignment. The other one maybe will be homework. Okay, so with this, it's not drawn. Usually when you are supposed to draw, okay, students struggle because they cannot picture the situation. So you have a triangle ABC. So indicate your triangle ABC, so solution. And let's see what will come out. Triangle ABC. Oops. Okay, so my triangle is not that neat. But don't worry, you will use a straight edge and never draw in ink. Okay, and don't draw also with your free hand, like I said. Triangle ABC, you are told AB is what, 5 cm. Okay, then BC is what, 8 cm. Centimeters. AC is 6 cm. This is what we have. So we are picturing the situation. Okay, that P is a point on AB, so P is supposed to be on this line. Do you agree? Such that AP is what? 2. So from A to P should be 2. Because the whole of this is 5, it means P will be closer to A than to B. You get the point?
Yes, sir.
Okay, so though you are drawing and you are not drawing to scale, it should still make sense. Okay, so I'm going to place my P, okay, here closer to A. And this I know is 2 cm. Okay, so automatically this becomes 3 cm. Okay, now let's go. The next one, what do we have? The line through P, okay, parallel to BC. Okay, the line through P, parallel to BC. So this is what your BC. I want a line through P, parallel to BC. So the line will be of this nature. Is that clear? It cannot be this. It can, you get the point. Because it should be of this nature. We'll meet at what? Q. Okay, so let's see the line through P, parallel to BC, meet at what? Q. Okay, so let's see. In this case, I have a power line here. Okay, parallel to BC, meet, okay. So in actual fact, this is where you are supposed to get your Q. Do you get your, I mean, the point that I've made, is it clear to you?
Yes, please.
Are you sure? I will give you another one,
Yes,
but you will bring out the diagram yourselves. So make sure you get it, okay, from the explanation. If you don't get it, kindly let me know so that I will throw a little more light on it and it will be good to go. So you are fine. Do you all agree that that's supposed to be the picture?
Yes, please.
Okay, so now that you have this, okay, you should be good to go. So you know how to identify your similar figures. So you are asked to find the length of PQ. So you are asked to find this length. Okay, and also the length of QC, this length. Okay, so take note, it's the entire length here. Where is, so the entire length here, that is 6 centimeters. Okay, and with this one too, you know, so your similar triangle will be triangle, your bigger triangle, which is triangle A, B, okay, then was C. Okay, and your smaller triangle that we have there. So you come back to the triangle that we started with, basically, that nature of triangle. So AP, okay, Q. So they share a common angle at A. Okay, then we know because this is parallel to that, the angle here will be equal to that. So I'm going to indicate this angle here is equal to this. So the angle at B will be equal to the angle at P here. Okay, and the angle at Q will be equal to, so I will use double arc. So angle at Q here should be equal to the angle at C. So automatically, so now you have your similar figures. And the side that you know, indicate the side and use it to find whatever that you want to find. Is my point well made?
Yes.
Hey, Prof. Leroy. Okay, so wait for the video, then watch. Okay, that's why you have to. Okay, so this one, we started the lesson from the beginning. So it's not a continuation of another lesson, but maybe you missed the first lesson, so you shouldn't be able to relate. Okay, we started from the scratch. Okay, so we are going to end here. Okay, and there's a password. Once I've explained, okay, when you look into your past question, if you look at the solution, you should be able to relate. But try and do it yourself and cross-check whether your answers are right. Okay, so on that note, okay, let me ask, do you have any questions? Any questions? Before I bring the curtains down finally, are we all fine? Okay, all right. Okay, so thank you very much. If that's the case, if you are fine, okay, God bless us all.
If you send assignments.
Yes, I will capture it and send it to you as usual. I'll put it on